Siri_bot says Siri_bot has joined Cerebro Love.
Okay. I don't think I'm going to solve this in one go, but we'll just start it. Your next test to build an inverter component using the NAND component. From this level on, we don't need to consider the mechanics of the underlying switches. While physical NAND gate requires a connection to a power source, we don't need to show this on the diagram. All components are considered implicitly connected to a power source. We can now concentrate on the logical input-output. Okay. Oh, wow, there's my NAND. Okay. A NAND component has been added to the toolbox now. Next task is to build an inverter component. An inverter component has a single input and a single output. The output should be the opposite of the input, so 0 for 1 and vice versa. Inverter. Okay. What's this do? Okay, I need to invert. So this is... Okay. 0 needs to be 1. 1 needs to be 0, so... Can I drag it to both? Nice. Oh, yes! This is fine. Actually, this was not hard at all. Wait. There you go. No, not hard. I did do NAND. I did it in a non-incognito window, so. Next has to build an AND gate using only NAND and inverter components. You might not need both kinds to solve this task. Okay. AND gate's output is 1 when both inputs are 1. Is 1 when both inputs are 1. Okay. Maybe. So if these are both 1, inverts the input. So they both need to be 1. And when this one when both are 1 is 0. I'm definitely going to use NAND. I don't even know. I wonder what NAND that stands for anything. Yeah, and then I just invert it. I think. Because the only time this will give 0 is when they're both 1. And then in any other case... Okay, this is significantly easier than... this NAND thing was like so freaking hard. Oh my god. I was on that forever before I finished it. This is optimal. Yay. An OR gate output is 1 when at least one input is 1. That makes sense. Would I use AND here? No. When at least one input is 1. Huh. Let's check out NAND. NAND is pretty useful. And at least one output is 1. Maybe not NAND. Let's see. Let's check everything. It just inverts. Actually, I might need the inverter. AND gate. Both inputs are 1. With the NAND gate. I shouldn't have called the last level easy. Of course, I grab XOR. How would I do this? Both are 1. Just one of both inputs are 1. Wait, maybe it was something like this with the inverter. Because if both inputs are 0, that's the only time I don't want it to output 1. So I invert both. Right? Like, invert both. Invert. Drag. Drag. Okay. Nice. And then after they're inverted, yeah. I mean, just put them into NAND, and then I think it'll work. Hell yeah. XOR. I still kind of want to do it, honestly. XOR's gate output is 1 when the two inputs are different. Yeah, right. I'm gonna have to think about this one. Just like the last one. What should I do? I still have like a ton of content I'm about to get through, so. Oops. Wait. Where's my NAND stuff? Did I close it? Oh my god. No, I wanna. It's fun. It's too fun. I don't want to do math. Wait a second. The two inputs are different. Oh, yeah. XOR. Wait, we have an OR here, but I never made an OR. It just like, oh yeah, I'm stupid. I literally did it. I literally just did an OR. feeling like if we use an OR, we have two outputs that we want, but then we don't want this one. No, we're not going to use an OR. We're going to have to, wait, what, and
Storm2 underscore Pain says hello.
Hello.
How are you?
Okay, I'm pretty sure we're just going to need NANDs and inverters. Pretty good, pretty good. And get apple 2 R1. How would I do XOR? I believe the two are different. 1. Yeah, I think this is going to be a lot harder than and or and the inverter by a lot. Because they're different. No, I don't have any ideas right now. I'm gonna keep thinking. One. Maybe like some kind of process of elimination. Like, just like actually maybe and seems like a good, nice choice. No, maybe. Or maybe if I can find anything about one of these will like and or NAND can like eliminate one of these options. Possibly. NAND and seem to be about equal with what I think I might try to do. But NAND's a better choice because it'll give me 1 for these two. But this one needs to become a 0. That's about it. So I think if I start thinking with the NAND block first. So then, how can I fix this?
Corrupt Converter says, who are you?
Who are you? No, who are you, Corrupt?
Corrupt Converter says, are you here?
No, and I'm not friendly.
Corrupt Converter says, are you close?
No, I'm super far away. You'll never find me. 0.
Corrupt Converter says, where are you?
Behind you. I love when it says that. XOR
says, how old are you?
XOR is significantly harder than the other ones, than making the other ones. The other ones weren't hard to make, except NAND. NAND, I hate you. NAND took like 2 hours to make. Yeah, I did it off stream. But I kind of challenge you if you can, like, without looking anything up, because I didn't Google anything. I didn't even Google what NAND was. Like, I kind of wonder if you can do it faster than me. Like, make the NAND block.
Converter says, what are you trying to do?
On level 1. Make XOR from scratch. Like, so I made NAND, I made inverter, I made and I made OR, and now I'm trying to make XOR. It's about, this whole game is really cool. It's like you can make a computer from scratch and it kind of teaches you how the logic gates, like the actual transistors, how does it make the logic, like NAND, inverter, and or XOR, and it's kind of cool. And then it goes up
Corrupt
and
converter says,
eventually...
so do you make it out of the other gates?
Yeah. Yeah, you make NAND and then you start making other gates out of NAND, which is super cool. NAND starts with just transistors. That's it. It's just like... It's so simple. Just input, output, like electricity or no electricity.
Corrupt converter says, let me think.
And then also, and then eventually you get to the register. So I think you'll make like your own register. So it's going up to like assembly and stuff, and that's cool. So it's hard to know where to start with this. I put the ore back, but I'm thinking maybe starting with NAND is a good idea because it has two outputs I want. I want these ones, but it has the 001 and I don't want that. So I need to find a way to cut this out. And if I can cut out this somehow, I'm not really sure how I'm going to do it, but whatever. If I can cut this one out and turn this to a 0, then I've made XOR. So how do I get rid of this? With my other blocks, I need to figure out a way to... If I invert 1, just put one inverter, which turns a 0 to a 1. Could that do what I want? I don't know, I just want to try it. Let's see what the output is. I just... drag this, connect this. I don't know, this might not work, but I need to see what happens.
Corrupt converter says,
nope, never mind.
A or B, N,
Did
A
not.
and B.
Didn't do what I think it would do. Why does it make them emojis? Oh, what you do? What got turned into an emoji? What the hell? A or B, bro? That's funny. Why did it turn into
Corrupt
emoji?
converter says,
A or
D,
sunglasses.
N,
A and sunglasses.
Storm2_Pain says,
wait, you think
A and B?
You think I can just use and OR just to make the just to get the XOR? Only, wow. I was gonna use... I guess maybe NAND's not the right choice. But so far I've only used like...
Corrupt converter says, or wait.
Yeah. Oh wait, no, wait, let me give an AND back again. Hold on. So I thought if I invert it one, but why does that...
Storm2_Pain says, do
why does
I and
this
B,
not work?
A and B, and A or B.
Also, guys, just in case, nobody cheat. Just making sure. Because there's a button that just will show you...
Says,
oh wait, no, there's not.
B, and
but these are... you can look up
A
solutions for these, but yeah, just don't do that. But you can make suggestions, that's fine. A or B and...
Storm2_Pain says, at corrupt converter you copy me.
You think A or B and then invert A and B? A or B?
Corrupt converter says, I just had it backwards a bit.
Okay, so OR will give me... that's right, so it could be either. Okay. I'll try it. A or B. And you invert both. Wait, no. Oh, sorry. Invert the OR? No. Oh, wait, no, you said and. Sorry, invert A and B. Sorry. But you can't do that. Because A and B need A and B. Like, they need the inputs A and B.
Corrupt converter says or gives you 0111, and gives you 0001, I and B that gives you 1110, so 0111.
But OR does have one of the outputs that I do want.
Gives you 0110, which is XOR.
So maybe you mean like another OR. Attach A and B. Because I need two inputs to make it work. Like this.
Corrupt converter says 0110 is XOR.
And then inverts? Invert. No. Unless I connected them wrong. But, wait. Let me think. I guess I feel like OR will be important here, though.
Storm2_Pain says no, you make it wrong.
And or AV. And AV. What?
Storm2_Pain says INV.
So A and B.
And A or B.
Invert the output.
Corrupt Converter says you need OR, AB.
Oh wait, I think I know. Okay. You mean and or connected to A and B, both.
Storm2_Pain says the last one linked to the result is a OR.
Invert the output of the AND. Why did I delete the other one?
Storm2_Pain says is and asterisk.
I can't just... I don't know the output of OR. So I need two inputs for AND. So if OR is one of the outputs for AND, then where's the other input?
Storm2_Pain says and the all.
Another AND. Wait, that's what I did originally and it didn't work.
Corrupt Converter says you need another AND.
I connected A and B. Wait, oh my god. Oh my god. Drag. Okay.
Corrupt Converter says no, it's not AB for it.
Invert OR?
Corrupt Converter says the
oh my god, you guys
inputs
are just so unclear.
OR.
The inputs are... Invert OR. Inputs for what? For the AND? I think it's because of stream delay, but... Wait.
Storm2_Pain says for AND.
Maybe.
Corrupt Converter says you can pass the output from one operation into another.
Oh yeah, I didn't even invert, you're right. Where was that? I don't even know where that goes in there.
Storm2_Pain says you forgot the INV.
I think it's supposed to go in the middle here. You said, but now I have to think about the logic of this.
Storm2_Pain says after the first AND.
After the first AND. Okay, let me fix it. And... Oh, it does finish. Oh, wow. Probably would take me like 5 hours to figure out. Okay, let me think about why this works. Which one's the least complicated one? I should start with the least complicated side of this tree. Maybe with the... This one's not getting inverted, so here, this one. So anytime there's a 1, it's 1. Okay. And then AND. If AND gets inverted, then only 0, 0 becomes 1. Interesting. 1. This is hard to watch.
Storm2_Pain says the first OR is here to take care of the value 1. The INV is here to the other cases.
Here, take care of the value 1. Okay, let me think about that. First OR, here, take care of the value 1. So just anytime there is a 1.
Corrupt Converter says when you INV it flips all the values.
When you invert it, it flips all the values, yeah. Wait, I think there's 4 binary values or 0, 1, 1, 1.
Corrupt converter says INVN equals 1110.
Yeah, so this one you said Storm. This one takes care of the 1. The AND, I guess, is job, and the AND and the invert combine. I guess they have something, but then we have another AND here, I think.
Corrupt converter says, inverting output
Has to do
of
with
AND.
removing this. 0, 0. Oh, I think this makes sense, because 0, 0 needs to be the only one with 0. Having this be 1 creates 1. Turns it to 0, so, oh wow. Clever.
Corrupt converter says
Cool.
so if you take 0111 and 1110, the 1 bits they have in common are the 2 in the middle.
You take 0, 1, and 1, 1, 0.
Storm2_Pain says the last AND is here to deal with the case A equals B equals 1 and the first for the case A equals B equals O.
You're good. Last is and is here to deal with the case A equals B equals 1. Last and first for the case A equals B equals 0. Ooh, give me some time to process that. I need to think about it. And the first for the case A. I'll start with the first one, I guess. First one, because it's, from the beginning. First one for the case A equals B. But in this case, for the first AND, I mean, this is, I guess maybe you're including the invert. Or not, maybe. Because if A equals B, I mean, A could be 0, 0.
Says this is a good time for an mispaint presentation.
A and B could be 0, 0, or it could be 1, 1. Oh, wait, you said the first AND. Oh, yeah, 0. Wait, no, but this one goes, never mind, 1. I think I still get it, though, by looking at the picture. MS Paint presentation. LOL, corrupt? This makes sense. This makes sense to me. And, need to be the same. Wait, no. Wait, that's not how AND works. Never mind, AND is the one with, anytime there's a 1. Oh, God. Wait, so what is OR? Okay, I'm starting to mix up AND and OR.
Corrupt converter says when I'm thinking about it, I'm not thinking about what A or B equal.
Oh, you're thinking about purely in binary, aren't you? Like the digits and the, yeah. Oh, sorry, and requires both to be 1. And if both are 1,
Storm2_Pain says me I think with true/false.
This makes sense. This is so clever.
Corrupt converter says my goal is to create the pattern 0110.
The output. Nothing about what A or B equal. Yeah. I'm thinking about it as true, false, too. Let's to create the pattern 0110. And by 011, oh, you mean what they're showing here, 0110? Interesting. Because of the chart. Oh. Wait, let me scroll up and see what you wrote.
Says yes.
So if you take 0111 and 0111 is 0111 or we're saying, so if you take 0111 and wait, sorry. Where is it? 0111 and 110, which is probably the AND. 0001. Wait, what's 1110? Which one's that? There are none.
Storm2_Pain says INV and.
Oh, invert it. Oh, becomes 1. Oh, because invert it.
Corrupt Converter says
1110
is INV.
Oh, you're right. 1110. Thank you. Thanks, Storm. So then, I'm going back up to what you wrote. If you take 011
Corrupt
and
Converter
1110,
says because N is
the 1 bits they have in
0001.
common are the 2 in the middle. So use and between them and you get 011. Oh my god. Oh. Oh wait, that's a cool way of thinking about it. Because of the bits they have in common, so that will be the output. Because that's what they have, that's what it would do. Whoa. There, I like, that's a cool way to think about it.
Corrupt Converter says or, AB, equals.
I love how it's the same logic. I mean, it's the same thing, but they feel so different somehow. Like these two different representations.
Corrupt Converter says INV,
to me,
and
feel
AB
different.
Equals.
Invert and, because and is 0001. Oh. Or
Corrupt Converter says
AB
so last step.
equals 0111. Uh-huh.
Corrupt Converter says equals 0110.
Where and AB. What's that? Okay, and AB 0001. So invert it. Yeah, that makes sense. So last step, use and on 0111. 10 goes 0. Wow. Okay, that's cool.
Corrupt Converter says and 0111 1110 equals 0110.
That's cool. 0.
Corrupt Converter says equals XOR.
XOR. Nice. That's really cool. 5 components use 11 NAND gates in total. But it's possible to solve using fewer. Oh, but it is.
Pain says
so this
you can
one.
Also think about what you need and divide the operation.
Guys, this is interesting.
One side of the OR for A is not equal to B, and one side for A equals B.
We did solve it, but we can actually solve it with fewer pieces than this. So this isn't the optimal solution, because it'll tell you when you reach the optimal solution, but it works. I think that's interesting. It's probably because we use too many, because each of these components has NAND gates inside of them. So I'm pretty sure you could, I don't know. Actually, I don't know. But like reduce the work somehow with just the NAND, cut something out. I don't know. But it works. Congratulations, you have built the fundamental logic gates. The next step is arithmetic operations. The processor needs to be able to add and subtract numbers. The first task is to add
Converter says what's the NAND pattern?
You figure it out. I spent 2 hours doing it. I did get it myself. Try it. Go on to log into the game and play level 1. It's not done in my case because I did do it. I just did it in a different browser. So that's why it says.
Converter says I don't know what NAND is.
No, it's literally with the circuits. It's making the first. Oh wait, I should show you. NAND. This is what NAND does. But it's using like the actual like electricity and the power. NAND makes, you need NAND to make invert.
Converter says what pattern is NAND?
It's interesting. Yeah, you need NAND to make invert, you need NAND to make and you need NAND to make OR. And then XOR, we use these other ones, but I'm pretty sure you could have used NAND.
Converter says, okay, so I know how the last step could have been optimized.
What? Already? Really? How did you come up with that so fast? Really? Okay, let's go back. Let's go to Let's go to XOR then. Alright. We could have done NAND AB. Okay. So I'll just rebuild it from the beginning so I don't mess it up. Put this one here. Wait, let me put the new
Corrupt
solution.
Converter says because that's what we were aiming for with INV, and, anyway.
Oh, you're gonna... Yeah. So with NAND AB...
Corrupt Converter says INV, and, AB, equals 1110.
Mm-hmm. Oh! You're right, and that's what this whole AND invert is equivalent just to the one NAND block. What the... Okay. I guess I'll disconnect these, but I'll keep these two up just because to show that we did that. That's... Wait, it actually doesn't, oh wait, because I don't have B connected correctly. Yeah, you're right. Dang. Okay, maybe the binary thing is really a really good way to think about it, because you came up with that really fast. Wait a second. How fast can you, if you can optimize it that fast, then how, oh yeah, we did it. Oh wait. Oh, it's because I need to delete those blocks. Here, I'll just delete the blocks. These, because we're not using them. And then it should say optimal. Wait. Oh, this uses the fewest possible components. But it is possible to solve with a lower total of NAND gates. Wait, we can optimize it more than this. Isn't that crazy? I don't know what will you do? Lower total? But it says we have fewest possible components. Doesn't that like isn't that like the opposite? Isn't it like contradicting itself?
Corrupt Converter says we didn't use any NAND gates before.
Oh, that was the other solution. So it's saying, yeah, it's saying we can do it with the and the invert too. So we did it. So we did it with, this is the lowest components, so. Wait, but actually, it does say we have eight NAND gates in total. Because remember, there's NAND gates. Oh, wait, is it because my other previous ones aren't optimized? But no, they were, I swear. It said, let's check out, hold on. Let's check out, and this is optimal. Yeah, they were all the other ones I did were optimal, so. Oh, it's because my OR, damn it, because my OR isn't optimized. That's why the NAND, I don't know. I guess I could have done a better job. I don't know how. Oh, it's because I have this one dragged out. It's stupid. There, optimal.
Corrupt Converter says
Oh,
I
it
can
still
think
says
of
this. I
other
don't know
jank
why.
ways to
Whatever.
do this LMAO.
Yeah. But yeah, this one has 6 NAND gates. Still possible to solve with total. I don't know how you solve this with less NAND gates. Like, I think it's fine. I don't know why that message is there. But yeah, it just says there's 6 because there's NAND gates that make up the AND and the OR. But my other solutions were optimal, so this should be the lowest amount. If it's the lowest amount of components, it should be the lowest amount of NAND. Oh my god, it probably means one of the ANDs or ORs can go away.
Corrupt Converter
like,
says, does INV use any NAND gates?
Let's see. You're right, it's a question. Yes. There's a NAND gate. NAND is NAND just makes the invert, which is fun. Let's see how many I use. This one has one, and has one NAND gate. And...
Corrupt Converter says how many NANDs go into making AND?
How many NANDs? Oh, one. One NAND.
Corrupt Converter says 2. Okay.
Yeah, but my NAND was optimal. Well, these previous ones are optimized, so I still don't get why this is. Maybe this is a bug. Solve for the lower total NAND gates. Because how? We use the minimum number of components, therefore we use the minimum number of NAND gates. Because these components are optimized, so it has to be the minimum number of NAND. Wouldn't you say? But is there any that uses more than one NAND gate? Wait, maybe I should look at that first. One NAND, because there's one that used... Did I use two NANDs?
Corrupt Converter says,
oh wait, invert uses one NAND, but it shouldn't... I need to use invert. Maybe this one I could have... No, wait, but this was still... It says optimal. It's optimal. Yeah, that one is just 3, though. Okay. What about OR? What about OR? You mean in the XOR, the OR here?
Corrupt Converter says, well, to figure it out, I'd have to see what it looks like fully expanded out.
I can't fully expand, but I can go back to what OR looks like. This is OR. This is like the OR block.
Corrupt Converter says, like written all with NAND gates only.
Oh, lol. What inverse made of NAND? You just have to like remember what all the pieces look like, because there's no way to like make it expand, but I think it's fine. I think it's optimal. I don't know why it says that. I think it's optimal. Unless they lied in the previous levels when they told me my other pieces were optimal. Unless they lied. It should be good. Half-adder. Congratulations, you built the fundamental logic gates. The next step is arithmetic operations. The processor needs to be able to add and subtract numbers. The first task is to add 1-bit numbers together. The result will be a 2-bit number. You will need to understand the binary number system to solve this. Yes. You should. It's fun.
Corrupt Converter says I should try this out.
And tell me, wait, time yourself. When you do the first level is NAND. You have to make NAND with the circuit things. Tell me how long it takes you, because it took about 2 hours. I didn't actually time myself, but it literally took like 2 hours, so. Yeah, I was on it for like a really long time. But whenever I would take any like short breaks in between like cleaning and stuff, I would just like see if I could solve it, and then I would give up after 5 minutes, and yeah. It was really hard. But I feel like, I don't know, you do these things fast, so. I wasn't sure if I would be able to do it by myself, but I did, so I'm really happy. Because NAND is like the foundation of computing, I guess, because this is where you start from, so I was really proud of myself. Better. You will need to, yeah, blah, blah, blah. An add component that adds 2 bits. Oh, I have to make the add component with NAND, invert, and or XOR. The output is a 2-bit value. The H output is the high bit. The L... Oh, high and low, yeah. L is the low bit. A, B, H, L. So I need to make it add 1 in binary, too. Number 1 is... That makes sense. 1, 0. Wait. AB. That's 2 bits. Wait, why is the output this? For this row. Oh, because 1 is okay. Plus 0 is 1. 1 is 2. Oh, I get it.
Corrupt Converter
Never mind,
says
I'm done.
next step, write 16-bit floating point base 2 logarithm.
That's not... Shut up. I can barely do logs. No, I don't want to write that. No, no, no. Okay. So, so 0, 1, 0, 1, 1. Oh, wow. Oh, this time I have two outputs because I'm adding. That's cool. 1, 1 is 1, 0. How do...
Garcus says
This got
basics
hard
of
really
computing.
fast.
Takes me back a few years, working with simple logic gates.
Aww. Yeah, it's amazing how this is actually simple logic gates are really complex. Well, more than I thought. Like, this, I don't know. This was hard. I had to get help. I had to seek help from chat, so this was hard. But I get it why it works, and it's also really cool how NAND is the same as and invert it, which is really cool. But it's also kind of funny how
says it's just more thinking to do the same simple things.
Yeah, it's funny how and invert are actually made up of NAND in the inside, so it's like, you know, extra work for the computer, I guess, because it's like NANDing in the inside, but it ends up equaling the same anyway. So, you know, stuff cancels out and stuff. Yay! Wait, delete you. Okay, half adder. Now there's even more to think about. Now that we have two, instead of two inputs, well, now we have two outputs to match the inputs. It's gonna be, that's annoying. And I hate how each of these little things can only plug into one thing. Two. I'm never gonna make it to the register section. This is so hard. Okay, let me just review what these things do. I don't even have a plan. I'm not sure how to approach this.
Corrupt Converter says I did this in sophomore year.
Lol, for fun. Amazing. Outputs new. And if and only if both inputs are 1. XOR. We had, I don't know, maybe not. Let me look.
Corrupt Converter says it was 3-bit inputs though instead of 1-bit inputs.
Wow. Let's see. So each of these gives one output, so I need to do it like one column at a time. Like one column of like ands and crap, all of these for the H column, and then one for the L column. That's what I think. That'll be my plan. To tackle each part, and then plug it into H and I. One column, yeah, because I was like, how do I do like both? But I think I just need to do it like that.
Converter says yes, one column at a time.
We'll start with the first column, so 0, 0, 0, 1 is what I need. So I just need the 1, when it's 1, 1, is when the first column needs to be 1. So that's within, like, what is and? And is what I need? Yeah, and for H, because that gives the output I want. Nice. Okay. Next column is the second 1, 1, 0, 1, 1, 1, 0. XOR, right? That's what we just made. And it was the 0, 1, 1, 0. Oh, wow. Okay. There you go. Sometimes it just takes me time to think about it. It just brain loads really, really, really slow. There you go. Oh my god! It's okay, but we have an add, so that's good. Now we have add. An add component, okay. You have now built an adder that can add 2 bits. But to add larger numbers, we also need to take a carry, oh no, from a previous addition into consideration. This mission is to build an adder component that adds the 3 bits A and B and C, where C is a carry bit. A and B and C. Oh my god. I like the 2-bit add more. The output is a 2-bit value. Oh yeah, because 1, 2, 3 is the 3 in binary. It's just so weird. Okay, the H output is the high bit. That was the low bit. It supposed to be C.
Corrupt converter says it's just ABC.
Oh yeah, ABC. Okay, so still probably doing 1 column at a time. Let's see if this will still work or something. But A plus B plus...
Corrupt converter
oh,
says
A plus
the bit
B,
about
so like
C being
add
a carry
A...
bit isn't helpful information.
I don't know what to do. Maybe there's a multiple add, like add AB and then add the C. But wait, this has 2. Oh yeah, this one will have 2 outputs because that's what we just did. H and I. Okay, never mind. Maybe just 1. The bit about C is being carried but isn't helpful information. Yeah, that confused me. That threw me off because just adding like 1 plus 2 is 1 plus 1 is 2, and then this is 2 in binary. Like, what the hell was it talking about? A carry bit? Like, oh wait, but it is. Yeah, what? Why did they say that? It didn't. I don't feel like it helped me. Unless they're not actually. Unless this is like, they're not actually showing what they're what it really is. Like maybe they're like showing it at a higher level than it really is. So in reality, there would be some kind of other thing, carry bit, but it's not actually doing that. I don't know. I have no idea. But yeah, that seems weird that they said that to me. I think so too. Well, if I was to just plug in A and B, it would just do the add thing.
Corrupt converter says the carry bit is relevant when you're on something other than the first bit of bitwise additone.
Carry bit is relevant when you're on something other than the first bit of bitwise. So other than the first bit.
Corrupt converter says,
there's 2
well,
bits
I can
in the
tell
output.
you what the first bit output here will be easy.
The first bit output here will be easy. You mean the H? You think will be easy?
Corrupt converter says the second one, need to think for a second.
Okay. Well, let's see if I can even do the H at all.
Corrupt converter says the first
really?
bit is rightmost.
Oh, it's right to left? Wait, so, what are you saying? Like, are you talking about the L column? Which column are we talking about? The L for the output? Or are we talking about the C column for the input?
Corrupt converter says that one is really easy.
L, okay. Easy. Okay, well, I'll do that one first then. 0, 1, 1, 0.
Corrupt converter says L is easy.
Okay, sniff. How? One. Wait. Let's think about it. Just trying to see if I can take a pattern or something. 2
Corrupt
blocks,
Converter
okay.
says you can do it with 2 blocks.
What if I do end up doing it, but what if I do it with like 50 blocks and then it just works? Does that mean I win? Oh my god, it's so hard that there's 3 inputs now. I hate it here. Wait, maybe I should go back to add, because how add?
Corrupt Converter says think about it in binary.
In binary. I mean... Oh, maybe you're saying like the ones... So this is like the ones place, but, you know, for binary. But, because it... Yeah, I guess it's still called the ones
Corrupt
place.
Converter says binary addition.
So
What
then
happens to the bit when you add
it's
1?
just... Okay, if I put A and B... Maybe I can just do it like... Wait, what am I doing? But then I would need... Oh my god. Because it's 2 inputs to it. Well, I can't just... Never mind, this can't work. Because this has 2 freaking outputs, it doesn't just give me the 2 numbers at it. So hope it. This is difficult. With 2 blocks. I don't know about this. I don't know if I'm gonna end up using this at all. Maybe. Let me see, it was or. Maybe something with XOR. No. Wait, what does the hope thing say for... Oh, better. But I'll need 2... Add. I think... Move it. Like in binary. Well, anytime there's 2 ones, there will never be a 1 in the output. But only 2 ones. So like
Corrupt Converter
and
says
or
H
something.
seems kinda inconvenient though, but maybe I'm thinking stupidly about it.
Oh, but you know what? I think that's fine. Like, sometimes it's good to just have a solution because I don't even have one yet. So Who knows? Your solution could be, maybe your solution could be optimal. I don't know. I just feel like I don't know how I'm gonna do it. Still, I don't know how I'm gonna do this, but like, and feels somehow like it should be somewhere. It's just hard because there's three inputs. I'm not sure how I'm gonna use this. I don't know. Best candidates so far seem like add and. I don't know. Maybe XOR. I don't know. Probably not. I'll just put it all the way to the side. So if I add it, because I do think then I have two outputs, and that sucks. I just wish add would give me one, but maybe it's like all I care about is one of the outputs. Maybe it's like there's one that matters, and I just need to use the one for the I, because I'm still solving for I. This probably is not going to be optimal either, but whatever. Because I want there to be, I think I can do, yeah, if I keep an add here, this will be 1, this will be 2. Oh, okay. So I need this to be first column to be 1. So I just need the I column, L column, sorry. I need the L column for this. And then I'm going to use like an AND or something.
Corrupt converter says, oh, I think
1.
H can be done in 3.
And. But also, oh wait, this needs to be 1 if it's 1. Wait, it just can't be 2. That's right. So I just need to eliminate 2. Wait,
Corrupt converter
I want this
says,
column
let
then.
me think about it.
Never mind. I think I want this H. Oh god. Add. Because if it's 2.
Corrupt converter says, oh, interesting.
Then this is 2. If there's one more, so 1 plus another 1, then this needs to be 1. And if there's 0, it needs to be 0. So what block do I use for that? 1 and 1. Is that where AND comes in? But this takes 2 inputs. Oh yeah, that's what I need, because it would be this. But this might be the wrong block, honestly. Well, that's awkward. Okay, that's clearly the wrong block. No, it doesn't make sense. No. Wait, let me think. I think something goes in here. So this is 2. So if it's 0, then 0 will be 0. Then we don't want it. It should be 1. So 0. Oh wait, I already have an X over here. Like maybe XOR invert it. And this is actually what I want. Invert. Damn it! Oh wait, no, I didn't connect it. What the hell? Huh? Oh, I'm sad. It doesn't work. What? I thought that's what I needed. I probably just made like a logical error. My thing probably just doesn't work. One zero. Oh, no. This would have been one if it did what I thought it was supposed to do. It's sad. Bro, this whole thing is super visual. If I can't solve this with just this, with all these helpful visuals, there's no way I can write assembly where I have no visuals. Oh no, addition could be so difficult. Okay. Let me try to think about it again. Where's my phone battery at? I'm gonna plug my phone in. I swear to God, if I solve one of these columns, then I'm just gonna go do like math or something. Like the easier stuff on Khan Academy, because I'm still trying to finish the other stupid curriculums. Yeah. This is so difficult.
Corrupt Converter says I can't figure out what the 3 solution is for this.
Oh, are you working on your own computer? 3 solution? You mean like there's a more optimal one and you're trying to like figure it out? Did you get it working? Did you solve for H? Did you get H and I? Because if you did, like, good job.
Corrupt Converter says no, I'm reading from here.
Reading what?
Corrupt Converter says Tkarka says there's a solution for the whole thing with 3 blocks.
Goes to 1 0. Oh my god! For the whole thing with 3. No way. It'll solve for H and L with 3 blocks. This is crazy. I have no idea how you would do it. This is so hard. Okay, well, I'm gonna do a really unoptimal solution. If I can even find a solution. I'm just trying to think how I could get a solution. I mean, I'm going to need an ad block somewhere. I'm pretty sure. I could bet a penny that I'm gonna need an ad block. I mean, not an ad block. I mean, yeah, an ad block. I was getting... Wow. I was thinking about, like, ad block as in, like, your browser's ad block, but this is a different kind of ad block. Oh my god.
Corrupt Converter says an ad block.
Yeah. An ad block, exactly. That threw me off for a second. Okay. So... Wait, did my pattern not even hold up? Let me just check every column really quick. So if there's one, or... Yeah, it's just as long as there's not 2 ones.
Garcus says some of my professors would
Or the
make a few turns
zeros.
in their graves if I was not able to solve these things.
Oh no, your professors would kill me. Well, I would. Well. Russian dead, huh? Yes. Well, good thing I've never met them because they would go after me, for sure, and drag me drag me to the grave with them. Back to their grave. Well, what I wanted to do doesn't exactly work all the way because there's this 0, 0, 0 one, which would not give a thingy in the one column. I need to scrap this. I don't think that'll work. I need to think of a different kind of solution that actually will work. A real solution. But what kind of solution? I'm gonna need add. And how would I handle if all 3 are 0? Making sure that L is 0 in this case too.
Garcus says or you would learn faster with them. I had some really good profs, who made it really easy to learn even hard concepts.
Wow. That's cool. Maybe I can cover for it somewhere. Like here. Wait, I don't know. Hmm. Maybe. You thought of something, correct?
Corrupt converter says or equals 0111, and equals 0001, NAND equals 1110,
And add
X
block
or
takes only
equals
2 inputs.
0110, add equals 0001,
Yeah.
0110.
I have another add block already over here. I was thinking it's gonna come into play somehow. I just don't know how. Put all these things together. I feel like, yeah. Oh, wait, you're writing it down? Or
Corrupt converter says writing this down to think about it.
or and 1 NAND XOR add. That equals and XOR. Wait, what did we do on the add one? Oh yeah, it does. We did and XOR. See, I already forgot how we did this. Which by H and the L. And an XOR. Oh, it's fun. And I have an and an XOR over here. They just seem like relevant. Like they'll be relevant again, maybe. Or could be. 2 ends. 3 inputs to add. Add block takes only 2 inputs. Yeah. Because it only takes 2, which is so annoying. Wait. There's no way you could do this with 3, is there? Because if you just... Oh no. Well, now I'm gonna put this one over here too. A and B. That just gives me... This was 2.
Corrupt Converter says add block is like a free 2 blocks though, gives you both AND and XOR, so I feel like it's probably important for full adder, but I don't know.
For 4, I see. For 3. But you found a solution, right? I assume you did, since you're looking for the 3 solution. I assume you have one though. Yes, nice.
Corrupt Converter says yeah, I know a solution.
Alright, once I figure out the solution, I don't even know if I'll go for the 3 solution, because even you haven't found the 3 solution yet, and I can't even find a solution for the low column. Like, jeez. One. Well, this is point this L. Maybe this is what I need for the L. Nice. Oh shoot! No, this one's messed up. Oh yeah, because there's one, but the 1 is here. Never mind, it's not messed up. It's just, but the H is okay. I did solve the L. Because you just need the ones, you know, this will give you 1, just add the other.
Corrupt Converter says
1 should be, okay. So, now I just need to figure out how, the hell. No way is it like, wait.
Garka says there we go. Progress made.
I know, I made some progress, I guess better than what I was doing, so, oh my god. Alright. Should I keep working? I don't know. I almost want to go back and do like, cause I still need to finish this stupid thing. Oh no, I'm about to lose my streak. Wait, this week. I should. I'll come back to. Wait, where's the thingy? I'll come back to this with a fresh set of eyes and after I like do this. Take a break and do this unit test so I can finish this thing that I've been on for so long because I've been doing it, so I can finish all the curriculums on Khan Academy. Oh, it's gonna take me like so long to do this. Like to finish everything on Khan Academy would take forever. Let's see, I better not get anything wrong. Uh-huh.
Momedy
Math.
says of math where it
Yeah.
failed.
Oh. But it's, hey, salt samples. That's me. Like, let's go ahead. How many?
Corrupt converter says
5.
samples of salttoserenity.
That's me. Yes. Samples. The See, there's enough samples for all of you.
Corrupt
I
converter
think there's
says
at
buried
least.
with a math
I mean,
textbook.
there's not more than 5 peeps buried with a math textbook. Where's this? Oh, the dear. Probably this one. Really? Good job.
Corrupt converter says oh I might have
Okay.
the 3 solution.
Gotta go. I'm helping my family take. I got texted. Helping my family take a bunch of stuff to Goodwill. So, but it's okay. But I made progress in the NAND thing, and I really wanted to finish. This. I'm gonna be in 5th grade forever. I'm never gonna get to finish. It's okay. Khan Academy automatically saves your progress, so I won't lose the unit tests. But yeah. I will not let this defeat me. I swear to God, I will keep working. I will solve this full adder thing.
Corrupt converter says
Because
am gonna graduate
if I
from
can
basic.
graduate from all this visual stuff, then I might have a chance at being able to finish Corrupt's assembly challenges. Some of them maybe.
Momedy says I'm on a 4-week streak as well.
Hey,
Smiley
yes,
face.
Do it. Don't lose your streak. You're my rival now, so you better not lose your streak, or I'll and yeah.
Momedy says XD.
And say, don't make me bring out the trash talk. Yeah, good job, Corrupt. Proud of you.
Corrupt converter says at carcass is it 2 adds and an or.
Well, if it works, then it has to. Wait, why don't you just put it in the thingy? All right, guys. I'll see ya. I'll be back later. When I come back home, I'm gonna start streaming again. So, I don't know. I'll be gone for an hour or 2 probably, and then I'll come back and then I'll start working on this again, and hopefully I can finish the full ad. Would be nice. And then I have to keep reading this because I'm like halfway through. And I need to go back and keep working on assembly. And then, if there's any time later, I don't know, do C or C# or something. Okay, bye. See ya. Thank you guys. Thanks for helping me too. Appreciate it. Thank you, Crap. Thank you. If they're still there, Storm. And then I always love seeing you, T-Carcass. Yeah. Thank you too, Mo. Okay, bye guys.